Good morning, all of you. Myself, Dr. M. Maivili, Assistant Professor, Department of Mathematics, KPR Institute of Engineering and Technology, Coimbatore. Now we are going to see about one-way classification method. Before one-way classification method, we are going to see about what are the applications used. One-way classification method can be used to compare the effect of different treatments. Here, treatment is referred by given subjects to evaluate differences between groups, such as differences in exact scores between the students from the different schools. One-way classification observations are called according to only one factor, which means only one criteria. This is exhibited only column wise, and this method is also called completely randomized design, which means CRD. Working procedure. We have H0 and H1 here. H0 is called null hypothesis, H1 is called alternative hypothesis. Here H0 is denoted by there is no significant difference between the treatments. H1 is there is a significant difference between the treatments. Step 1, here we have totally 8 steps. First step is find the value of capital N. Capital N is denoted by the number of total observations. Total observation means total number of data in the given problem. Step 2 is find the value of capital T. Capital T is the total value of all the observations. All the observation means just total of the given data. Just add all the values of the given data. Step 3 is correction factor. Correction factor is called T square by N. T is already we know about what is T. T is total number of all the observations. The whole square divided by total number of observations. Step 4. Calculate the total sum of squares, which means TSS. TSS is nothing but summation x1 square plus summation x2 square plus summation x3 square up to minus t square by n. Here summation x1 square, x2, x3 are called column wise. Step 5 is SSC. SSC is called column of the squares. SSC can be written as summation x1 the whole square by capital N1 plus summation x2 the whole square by capital N1 plus summation x3 the whole square by capital N1 up to minus t square by capital N. Here N1 is represented by the number of elements in the column wise. Step 6. Calculate the error sum of the squares, which is called SSE. SSE can be written as TSS minus SSC. Then finally we have to conclude that step 7, which means ANOVA table. ANOVA table is analysis of variance table. Then conclusion. Now we are going to see about one of the problem. The problem says that a completely randomized design experiment with 10 plots and 3 treatments given. 3 treatments here A, B, C, and 10 plots is 1 to 10. And yield means the given values. Yes, solution. H naught. Already we know about what is H naught and H1. H naught is nothing but there is no significant difference between the given subject. H1 is there is a significant difference between the given subject. So we have totally 3 treatments like A, B and C. So A, write it as in the row wise. We have 4 values in first row. B is second row. Similarly, C values are in the third row. Yes, you have formed the total values. You have formed the values in the tabular column, which means capital X1 like first row, first column, capital X2 like second column, capital X3 is third column. This is the total of the element. Summation X1 is 16, summation X2 is 15, summation X3 value is 9. Finally, we have calculated total value. Total value capital T is equal to sum of 16, 15 and 9 is equal to 40. Then similarly find x1 square, x2 square, x3 square values of the given tabular column. Then finally calculate summation x1 square, summation x2 square and summation x3 square. Summation x1 square value is 84, summation x2 square value is 81, summation x3 square value is 35. Then now we are going to see about what is step 1. Step 1 already we know the total number of elements. Total number of the given problem is totally given data. Given data are 10. Second step is add all the values of the given table, which means capital T is equal to add all the values in the given data, that is 40. Step 3 is t square by n, which is called correction factor. Correction factor value is 160. Step 4 is TSS. TSS is calculated by summation x1 square plus summation x2 square plus summation x3 square minus t square by n. Already we know the value of summation x1 square, x2 square, x3 square and the correction factor. Finally, we get TSS value is 40. Then step 5, SSC. SSC is nothing but summation x1 the whole square by n1 plus summation x2 the whole square by n1 plus summation x3 the whole square by n1 minus t square by n. Here you have three column values, that's why we written as x1, x2 and x3. Here n1 represented by number of elements in each column. So first column you have 4 elements, which means 4. Second column having 3 elements, third column having 3 elements, like 16 square by 4 plus 15 square by 3 and 9 square by 3 minus correction factor. So finally we get SSC value is 6. Then step 6, SSE. SSE is nothing but TSS minus SSC. So already we have TSS value, which means 40. SSC value is 6. So SSE value is 34. Then we form a table which is called ANOVA table. ANOVA means analysis of variance. First one is source of variance. We have only one, that is column wise in one way classification method. We found only column wise. So between column is called SSC, between error are called SSE. Already we have SSC value 6, SSE value is 34. Then degrees of freedom of column value is C minus 1. C means number of columns, that is 3 minus 1, 2. SSE is 34. So capital N minus C is 10 minus 3, which is equal to 7. Then mean square. Mean square, first mean square of the column is MSC. MSC is calculated by SSC by C minus 1. SSC value is 6. C minus value is 2. So MSC value is 3. Then MSE value is SSE by N minus C. 34 by 7, which is 4.86. Next one, finally find the variance of ratio, which is calculated value of F. Here comparison between MSE and MSC. So which is the greater value? First we found which is the greater value. Here MSE is greater than MSC. So calculated value of F is written as greater value by smaller value. So we have greater value is 4.86 by 3. So which is 1.62. 1.62 is nothing but calculated value of F. Then finally find the tabulated value of F at 5% level of significance. Here MSE is greater than MSC. So find the tabular column in the value of 7, 2, which means 7 is MSE degrees of freedom, 2 is MSC degrees of freedom. Finally we get 7, 2 is equal to, we have a tabular value of capital F. Next, conclusion. Here comparison between calculated value and tabulated value. Here calculated value is 1.62 and tabulated value is 19.35. So here 1.62 is less than 19.35. Here calculated value is less than tabulated value, means we accepting the null hypothesis. So therefore there is no significant difference in the given treatment. Thank you.